Electric field is zero inside a cavity or hollow bodies like in a charged conducting spherical shell. Hello everyone. This is the second part of the lecture. In first part, we have done first 40 questions of the question paper of assistant professor, which was conducted in March this year by KEA. So let us proceed with the solutions. Firstly, I would like to mention that in my previous video, 2 questions which I solved were wrong. There was a mistake in finding the answer. So the options were also wrong. I want to thank the viewers. 2 of them have noted the mistakes and they let me know. That's why I'm correcting my mistakes. Also, I have pinned the same corrections in the first lecture also. I have pinned in the comment section also. So the first question was that about the magic numbers. Actually, magic numbers are 2, 8, 20, 28, 50, 82 and 126. I had missed 20. In that lecture, I had told that 20 is not a magic number. It was a mistake. 20 is a magic number. So, option B will be the right answer. So, please correct it. Next is question number 34. The value of root I plus root of minus I. Actually, I thought of solving this problem via some shortcut. That's why I tried to solve it in a simple manner, but then the answer was wrong. So that's why let's go with the actual procedure. So let's keep I square is equal to minus 1 in mind and let's try to solve it. Let's take square root of I first. Here, multiply and divide this I by 2. And then add and subtract the numerator by 1. 1 plus 2i minus 1 by 2. Now we know that I square is minus 1, right? So I will write here 1 plus 2i minus plus I square divided by 2. It is right, isn't it? Now this numerator is of the form a plus b whole square. If I rewrite it, it is like this. 1 square plus 2i plus I square by 2. So this is of the form a plus b whole square. So I can write square root of I as square root of I plus 1 whole square divided by 2. Now this square and square root gets cancelled from the numerator and it will be I plus 1 by root of 2. In the same manner, I can solve for square root of minus I. This can be written as, again, if I add and subtract 1, I can write it as 1 minus 2i minus 1 by 2, or I can write minus 1 as I square because I square is minus 1. So it will be 1 minus 2i plus I square divided by 2. So this is in the form a minus b whole square. So square root of minus I will be square root of 1 minus I whole square divided by 2. Again 2 and square gets cancelled and we will have 1 minus I by square root of 2. Now I can easily add them, isn't it? Square root of I is 1 plus I by square root of 2 plus square root of minus I came to be 1 minus I by square root of 2. Denominators are common. So I will get cancelled and I will have 1 plus 1 is equal to 2 by square root of 2. This can also be written as square root of 2 into square root of 2 by square root of 2. Once square root of 2 gets cancelled. So my answer will be square root of 2. So option D is the right answer. Now moving to the next part of the question paper. We will start with question number 41. The question is the probability that 2 friends share the same birth month is. So for this what you have to do is you have to first understand what are the favorable outcomes. Means how many months are there? There are 12 months, right? So they are the favorable outcomes. Now what will be the total outcome? Total outcome will be one person will be born in any of the 12 months and the other person also will be born in any of the 12 months. Only thing is they will have the same month. So to find the probability, what we do is probability is equal to favorable outcomes upon total outcomes. So the favorable outcomes are 12 months upon total outcomes will be 12 into 12. So the probability will be 1 by 12. Option C will be the right answer. Next question is, for the function f of z is equal to tan of 1 by z, where z is equal to 0, is a non-isolated singularity, essential singularity, non-essential singularity, or removable singularity. Now there are two types of singularities. One is isolated singularity, the other one is non-isolated singularity. In isolated singularity, we will have removable singularity, pole is also one type of singularity, and essential singularity, and all this. This belongs to isolated singularity. Now what is isolated singularity and non-isolated singularity? If we remember this, things will become easy for us. Now this given function f of z, if this is not analytic at some point z is equal to a, but it is analytic at its neighborhood. So this type of function is known as isolated. Now the function which is not isolated is called a non-isolated function. The function f of z which is not isolated at that point z is equal to a is called non-isolated function. But there is one more thing which is very important here. Isolated singularities, they have finite singular points, and non-isolated singularities have infinite singular points. So this is the simple trick to find whether the given function is isolated singularity or non-isolated singularity. Now if the function f of z is given, and if this z is in the denominator, for this function if z is in the denominator, then only this f of z can tend to infinity, isn't it? If there is some, say it is 1 by z, then if z becomes 0, then only that function will become infinite. Now this is the case where the given function will be non-isolated. Now here the given function is f of z is equal to tan of 1 by z. This can be written as sine of 1 by z by cos of 1 by z. Now tan of 1 by z can become infinite if cos of 1 by z will become 0. Isn't it? That's why there is a possibility for tan of 1 by z to become infinite. That is, the given function is non-isolated singularity. So option A is the right answer. Only thing we have to remember is that for isolated singularity, the finite singular points will be there, and for non-isolated, infinite singular points will be there. Moving on to next question. If P is a non-singular matrix of order 5 into 5, then rank of P is. If P is a non-singular matrix of order 5 into 5, then rank of P is. There are 4 options, 5, 1, 2 and 3. See, if there is a singular matrix of order n into n, then rank of that matrix will be n. So this is very simple, right? So the given order is 5 into 5. Then this non-singular matrix will have rank 5. So option A will be the right answer. Okay, next question. The angle between P plus Q and P cross Q is. Now P cross Q means this P cross Q is perpendicular to the plane which contains P and Q. Isn't it? P cross Q, the vector product itself says that it will be perpendicular to the plane containing P and Q. Then the angle between P plus Q and P cross Q will be 90 degree. So option D is the right answer. Next question. If A cap, B cap stands for the commutator of two operator A and B, then A cap, B cap, comma, B cap, A cap is equal to. See, this is in a commutation relation, you write A cap, B cap is equal to A cap, B cap minus B cap, A cap. So I think option A should be the right answer. 0. Because A cap, B cap is also equal to minus B cap, A cap, right? So the answer should be 0. So this A cap, B cap is commuting with B cap, A cap. Option A is the right answer. Next question. A matrix is given and we have to find the eigenvalues of the matrix. See, whenever they ask for eigenvalues, no, what I do is first I find the determinant of the given matrix. If the determinant is 0, it means that the product of the eigenvalues is 0. That means one of the eigenvalue is surely 0. So let me find the determinant P. It is 1, 2, 3, 2, 4, 6, 3, 6, 9. This will be equal to 1 into 4 9s are 36 minus 6 6 are 36 minus 2 into 18 minus 6 3s are 18 plus 3 into 12 minus 12. So this will be equal to 0. So the determinant comes out to be 0. So the determinant is equal to product of the eigenvalues. Let the eigenvalues be lambda 1, lambda 2 and lambda 3. This is equal to 0. It implies that at least one eigenvalue is 0. So this let's keep in mind. Now let's find the eigenvalue. What is the procedure we follow to find the eigenvalue? We take A minus lambda I, right? We take the identity matrix into the eigenvalue. This I can write it as 1 minus lambda 2, 3, 2, 4 minus lambda 6, 3, 6, 9 minus lambda. This I will treat it with 0. So 1 minus lambda into 4 minus lambda into 9 minus lambda minus 36 minus 2 into and so on. I have lambdas, enough lambdas now. I have all the 3 eigenvalues here. So I can easily find the values now. This is equal to 0. So I want to save the time in the exam, right? I don't want to waste my time. So that's why I am using only the first term here. 1 minus lambda into 9 3s are 36 minus 4 lambda minus 9 lambda plus lambda square minus 36 will be equal to 0. So here 1 minus lambda will be 0 and here this 36 will get cancelled. 4 minus 4 minus 9 will be minus 13. So lambda square minus 13 will be equal to 0 minus 13 lambda, or lambda minus 13 will be equal to 0, or lambda will be equal to 13. And here lambda will be equal to 1. So I already know that one of the eigenvalue is 0. Other two eigenvalues I am getting is 1 and 13. So in the options I have 0, 1 and 13. Option D will be the right answer. Here by seeing the question, when I find the determinant, then only I came to know that B is the wrong answer because there is no 0. No, rest 3 options anyone could be there. But when I did A minus lambda I, then only I came to know about 1 and 13. Okay, next question. A vector perpendicular to any vector that lies on the plane defined by x plus y plus z is equal to phi is. So here phi is given, which is equal to x plus y plus z minus phi. Now if I have to find one vector which is perpendicular to this vector, means I do del phi. I will write it here. So del phi will be equal to d by dx into y plus d by dy into j plus d by dz into k into the given vector x plus y plus z minus phi. This will be equal to d by dx of x will be 1. So here only I is remaining. Same way here it will be j, and d by dz of z will be 1. So it will be k. So I plus j plus k is the vector which is perpendicular to x plus y plus z is equal to phi. Option D is the right answer. 48. What is the angle between vectors p and q if p cross q cross r is equal to half q and q is not parallel to r? Now when he says that q is not parallel to r, then only I say that option D is wrong because it is not parallel, right? So 0 degree will not be possible. But when I see this vector products, I feel that it should be 90 degree because vector products means all the vectors are perpendicular to each other. So option D should be the right answer. So like in previous video, if I am making any mistake, please let me know. I'll be glad to correct my mistakes. Next question is, which of the following observers is non-inertial? They have given 4 options. It is difficult to make a unique statement of inertial and or non-inertial aspect. A child revolving in the merry-go-round. A driver in a train moving with constant velocity. A man at rest. See, inertial frame of reference will have constant velocity. Non-inertial frame of reference is that which is undergoing acceleration or is being rotated with uniform speed. Rotation with uniform velocity is not possible because velocity keeps on changing direction in circular motion, isn't it? So we say that it is being rotated with uniform speed with respect to an inertial frame. Now this is the wrong option. A child revolving in the merry-go-round, yes, it should be true because we are talking about non-inertial frame of reference. So option B should be the correct option. If I see option C and D, a driver in a train moving with constant velocity means it is uniform motion, right? So this is an inertial frame of reference. A man at rest means if he is not moving also, it means that it is inertial frame of reference. So option B is the right answer here. Next question. A system exhibits invariance under translation in space and time. The following quantities will remain conserved. There are 4 options in which linear momentum, angular momentum and energy is there in option A. In rest all only two things are there. See, there are 3 laws of conservation, isn't it? The 3 laws of conservation are linear momentum, law of conservation of linear momentum, law of conservation of angular momentum and law of conservation of energy is so very famous. So option A is the right answer. Next question. A particle is moving on a sphere of fixed radius. The number of degrees of freedom for the particle will be. Actually it is sphere, no. First I thought that degrees of freedom will be 3 because a particle can move in x-axis, y-axis and z-axis. But the condition is given here. They say that the sphere is of fixed radius. If something is fixed means the particle cannot move in 3D. It can move only in 2 directions. That's why here option D will be the right answer. The number of degrees of freedom will be only 2. Okay, moving on. If this is not mentioned, no, if the fixed sphere is not mentioned, no, if it is, they are talking only about the particle is moving in a sphere and this is not there, then degrees of freedom will be 3. But for this question, degrees of freedom is 2. Okay, next question. The Hamiltonian corresponding to the Lagrangian L is equal to ax dot square plus by dot square minus kxy is. All terms have their usual significance. Here one Lagrangian is given. What is the Lagrangian? Ax dot square plus by dot square minus kxy. Now first to find the momentum px. How you find it? You differentiate dl by dx dot, the Lagrangian. So if you differentiate it with respect to x dot, you get 2 into a x dot. Okay. So my x dot, x coordinate will become px by 2a. Similarly, if I want to find the momentum in y direction, then I will do dl by dy dot. Then I get 2a into y dot. So my y dot will become py by 2a. Now you find the Hamiltonian. Hamiltonian is equal to summation p into q dot minus L. You can also write this q dot as a summation p x dot minus L. Now substitute. This will be equal to px into x dot. This is x dot and this is y dot. In place of x dot I am going to write px by 2a. I am removing the summation, so I am writing px. Now I will write py into y dot will be py by 2a minus the Lagrangian, the given Lagrangian, ax dot square minus b into y dot square minus kxy. This will be equal to px square by 2a plus py square by 2a minus In place of x dot square, again I will write px by 2a. I will substitute the values of x dot and y dot in the Lagrangian. X dot will be again px by 2a, but I have x dot square. So it will be p square x by 4a square minus b into py square by 4b square minus kxy. 1b will get cancelled, 1a will get cancelled, and px square by 2a, px square by 4a. If I subtract, I get px square by 4a. Again, if I subtract py square by 2a with py square, sorry, it is plus here. So now I subtract py square by 2a and py square by 4b. I get py square by 4b. Minus into minus will be plus kxy. So px square by 4a plus py square by 4a plus kxy. Option D is the right answer. Next question. The product of any generalized momentum and the associated coordinate must have the dimension of. See, if you don't want to think from the generalized momentum point of view also, if you simply know that some momentum is there, say that is P, and some coordinate is there associated with it, let it be R. Now what is the formula for momentum? It is mass into velocity, right? Into R. This is mvr, which is angular momentum. So option C will be the right answer. So if you want to see from this perspective of the generalized momentum, then it will be P into Q dot. Then again you try to solve it. Again you will get the dimensions of angular momentum only. Next question. A force F1 acts on a particle so as to accelerate it from rest to velocity v. The force F1 is then replaced by F2, which decelerates it to rest. Then 4 options are given which says that either F1, F2 are equal, they may be equal, they must be equal, they must be unequal, or we cannot say anything with this information. So what is mentioned here is that one particle is there, one force F1 is applied on it so as to accelerate it. It is accelerated, it is moving with velocity v. Now force F1 is replaced by F2 and this particle is decelerated and it is brought to rest. So F1 and F2, they may be equal or they may not be equal because they have not mentioned the direction here. If the direction was mentioned, if it was told that an opposite force is applied and the particle is brought to rest at its original position, then I would say that F1 and F2 must be equal. But they are not mentioning about the direction. So they may be equal or they may not be equal. So that's why F1 may be equal to F2. Option C is the right answer. Next question. The value of Poisson bracket is, this Poisson bracket is given x square and px square. See, for momentum, you remember that if there is momentum operator is there, then how it affects the x square is like differentiation. It is 2x. But here it is px square. So how you write is, first it operates itself. Px square will operate itself. So it will be 2 into px. That will come out. Now you use this formula again. Now again 2x into this 2px. This is this. And this is written as it is. So it will be 4x px. Option D will be the right answer. Next question number 57. According to special theory of relativity, a particle cannot travel with the speed of light because its mass will be 0, velocity will soon be infinite, mass will be infinite, mass will reduce. See, according to special theory of relativity, if I am talking about mass and the speed of that particle, then m will be equal to m naught upon square root of 1 minus v square by c square, where v is the velocity of the particle and c is the speed of light. Now, here the condition is that if the particle is having speed of light, what is going to happen? M naught by square root of 1 minus c square by c square. This will get cancelled and I will have m naught by square root of 1 minus 1, which will lead me to infinity. So, if the particle tries to travel with the speed of light, its mass is going to become infinite. So, option C is the right answer. Next question. The Lagrangian of a system with 1 degree of freedom is given by. One equation is given for the Lagrangian, and here alpha and beta are non-zero constants. If PQ denote the canonical momentum conjugate to Q, then which one of the following statement is correct? First you find the momentum, because in 4 options also he is talking about momentum, the value of PQ we need, and then we will find whether it is conserved or not conserved. So we have this Lagrangian is equal to alpha q dot square plus beta q square. Instead of writing q, I prefer writing x, because x gives the feeling of coordinate. Alpha x dot square plus beta x square. So now I can find px. Differentiate this Lagrangian by dx. Then you will have 2 alpha x dot. But in the question they are talking about PQ, isn't it? So this is PQ. So it is 2 alpha x dot, or it will be 2 alpha q dot. So we got the answer. It is 2 alpha q dot. So option B and C for sure will be wrong. And option A and D has the same value for PQ. Now we have to find whether this PQ is conserved or no. Now to find this, we know that if x is cyclic, then px will be conserved, or else it won't be conserved. Now to see whether it is cyclic, dou L by dou x should be equal to 0 for cyclic. Surely it is not cyclic, because I am not going to get 0 here. So it is not 0. So this quantity will not be conserved. Option A is the right answer. Okay. Next question. The Lagrangian of a free particle having rest mass m naught and relativistic speed v is given by. For a free particle, the Lagrangian is going to be minus m naught c square root of c square minus v square. Now next question. Scleronomous constraints are. Scleronomous constraints, they are the constraints which are not function of time explicitly. That means they are independent of time. So option B is the right answer. Rheonomous, they are function of time. They are dependent on time. Okay, moving on. Next question. Consider 3 vectors. These 3 vectors are given where I, j, k are standard unit vectors in a 3-dimensional Euclidean space. These vectors will be linearly dependent if the value of alpha is. See, to find the linear dependency, what we do is, we find the determinant and we treat it to 0. For 2i plus k vector, I write 2. There is no j is not given, so it will be 0. And the coefficient of k is 1. Then 1, 2, 2. Then 1, 1 alpha. Treat it with 0. 2 into 2 alpha minus 2 minus 0 plus 1 into 1 minus 2. This is equal to 0. So it will be 4 alpha minus 4 minus 1 is equal to 0, or 4 alpha minus 5 is equal to 0, or alpha is equal to 5 by 4. So option D is the right answer. Okay, next question. A particle moves with a constant velocity parallel to x-axis. Its angular momentum with respect to the origin is. Now, if a particle is moving parallel to x-axis, if it is moving parallel to x-axis, then what I get first in my mind is that angular momentum is going to be 0. But then we have to read the question carefully. Its angular momentum with respect to the origin they are asking. With respect to the origin. Here angular momentum is equal to mvr, right? Now in place of r, I am going to write y. Because it is parallel to x-axis. They are not telling anything about y-axis. So with respect to origin, angular momentum will be same. It will not change. That's why the word constant is the right option. Option C is the right option. Next question. Which of the following cannot be the eigenvalue of 3 into 3 matrix? We have to see 4 options very carefully. Here see, there is a complex number I. Here also I is there, and here also I is there. Here it is not there. But then for sure any matrix will have eigenvalues 1, 1, 1, right? Why not? Why shouldn't they have? And they can have this also and this also. They can't have this I, 1 and 0. So option A is the right answer. I will tell you the reason. Actually, if the matrix is real, then the complex eigenvalues, whatever the complex eigenvalues will be there, no, they always occur with its complex conjugate. See here, I has its complex conjugate minus I. Yes, both are eigenvalues. E to the I theta, for this conjugate will be e to the minus I theta. But here in option A, there is no conjugate. It should, if I is there, then minus I should have been there. Then only it would be a correct eigenvalue of the matrix. So this is not possible. I10 is not possible. Moving on. In figure, XY is an infinite line charge distribution. P and Q are points as shown. The ratio of electric fields at P and Q is. So we have to find the ratio of electric fields at P and Q. Here by chance, if you don't remember the formula also, it is very logical that the distances are same, isn't it? Here also distance from XY to P is A, and here distance from XY to Q also is A. So by chance, if you don't remember the formula also, you take the ratio, you are going to get 1 and 1 because same formula will be applied. There will be no changes if there is no change in distance. Anyway, let's go by procedure. At P, electric field due to an infinite line charge distribution will be, let it be E1, 1 by 2 pi epsilon naught lambda by A. It is at P, let me write P. Then at Q it will be EQ is equal to 1 by 2 pi epsilon naught lambda by A, because same distance is there. Now take the ratio EP by EQ. It is going to be 1. Now how we got this formula? We have derived this from Gauss's law. So option B, 1:1 is the right answer. So this will be 1:1. Okay, next question. When a negative charge is placed at the center of the sphere, the direction of the electric field on the Gaussian surface is. See, we know that if one charge is placed at the center of a sphere, then electric lines will go from positive charge. They will start from positive charge. They will emerge from positive charge. Means this is radially outward direction. Now in the question they are telling that negative charge is placed. Instead of positive charge, one negative charge is placed here. So what should be the direction of the electric field lines? It should be opposite, right? It should be radially inward. So option C is the right answer. Next question. The power radiated by an oscillating electric dipole is proportional to the frequency omega by. The total power radiated by any electric dipole, no, for that formula is there, and that formula is P is equal to 1 by 4 pi epsilon naught into P naught square omega raised to 4 by 3C cube. Now this is frequency. So that's why the power radiated will be proportional to omega to the 4. So option A is the right answer. Next question is the electric flux passing through a hemispherical surface of a radius r placed in an electric field E as shown is. 4 options are given. See, this word hemispherical surface is very confusing. They are asking electric flux passing through hemispherical surface. Anyone would get in mind that the area of hemispherical surface is this. It will be 3 pi r square. So there is nothing in the options such that such like 3 here. No 3 is there in the options. But what we have to imagine is that there will be a flat surface for this sphere, isn't it? For this hemisphere, isn't it? That figure they have not given here. So that we have to keep in mind. So this will be a circle. So area of circle is pi r square. Now our usual procedure can be done. According to Gauss's law, flux phi will be equal to closed integral of E into ds this will be equal to Q upon epsilon naught. Now this will be equal to E into integral of ds. This is a dot product. That's why I write cos theta. This theta is going to be 0. That's why cos 0 will become 1. E into integral ds. Or now the surface area is pi r square, because we are talking about the flat surface of this hemisphere, which is a circle. Sorry, it is E dot pi r square. So it will be pi r square E. So option B is the right answer. Okay, moving on to the next question. The displacement current arises due to, there are 4 options: time varying electric field, positive charge only, negative charge only, both positive and negative charges. We know that there is an Ampere's law. Ampere's law with a displacement current. You write it like this. For magnetic field, B into dl is equal to mu naught into IC plus ID. Now this ID is the displacement current, and this ID is equal to epsilon naught d phi v by dt, rate of change of magnetic flux. So this displacement current is arising due to time varying electric field. Option A is the right answer. Next question is the magnetic field due to a long straight current carrying conductor of radius r, where r is greater than r. Here small r is distance between point and the axis of the wire, and this is proportional to. We know that the magnetic field B is equal to mu naught I by 2 pi r. So this magnetic field will be proportional to r to the minus 1. Option C will be the right answer. Next question. When a voltage standing wave ratio VSWR in a transmission line is 3, the magnitude of reflection coefficient will be. So for reflection coefficient R, it is VSWR minus 1 by VSWR plus 1. Now VSWR is 3. 3 minus 1 by 3 plus 1. It will be 2 by 4 or 1 by 2. So 1 by 2 is the right option. D. Next question is the potential which exhibits the dependence of the potentials on the velocity of the charged particle is known as retarded potential, scalar potential, vector potential, Leonard-Wishart potential. Leonard-Wishart potential is the right answer, because this Leonard-Wishart potential describes the classical electromagnetic effect of moving electric point charge. This is describing in terms of scalar and vector potential. So scalar potential and vector potentials, they are included in this Leonard-Wishart potential. So this is described in Lorentz gauge. So option D is the right answer. Next question. A charge Q is located at the center of hypothetical cube. The electric flux through any face of the cube is. See, first imagine how many faces that cube has. It has 6. Somewhere in the middle that charge is placed. The charge Q is placed. Now total flux will be equal to, according to the Gauss's law, it will be Q by epsilon naught, isn't it? This is for all the 6 faces. This is total flux. So the question is the electric flux through any face, means any one face. What will be there? It will be 1 by 6, isn't it? 1 by 6, because there are 6 faces. Q by epsilon naught. So Q by 6 epsilon naught is the right option. Next question. The electric field of a wave propagating in the xy plane with wave vector k making an angle of 30 degree with x-axis is. So electric field of a wave propagating in the xy plane with wave vector k. There is an equation for electric field, right? That is E is equal to E naught cos omega t minus k into r. This k is a wave vector. Or if I write it elaborately, I can write as E is equal to E naught cos omega t minus kx cos alpha minus ky into cos beta minus kz into cos gamma. Means in xy plane angle is given, that is 30 degree alpha. This is for x-axis. This is the angle made by electric field with x-axis. Now what will be the angle made by electric field with y-axis then? The remaining 90 degree minus 30 degree will be 60 degree. And the other gamma. the angle made by electric field with z axis. This is also perpendicular. So this should be 90 degree. Now if I substitute, I get E naught into cos omega t minus kx cos 30 minus ky cos 60 minus kz cos 90. So this is going to become 0, and cos 30 is root 3 by 2, cos 60 is 1 by 2. So E will be equal to E naught cos omega t minus root 3 by 2 kx minus 1 by 2 ky. So the option C is the right answer. Next question. For an atom in the state of 2d phi by 2, the Landé G factor should be. Here the electronic configuration is given 2d phi by 2. Whatever is written here, it is multiplicity. And this is J, the total angular momentum. And see, actually how we find this Landé G vector is, this is equal to 1 plus j into j plus 1 plus s into s plus 1 minus l into l plus 1 by 2j into j plus 1. Now in this we need L, right? S, P, D, F. So for L, this is 0, 1, 2, 3. So our L will be 2. Now we know that multiplicity is 2s plus 1, which is equal to 2. With this I get spin. Spin is equal to 2 minus 1. It will be 1, 1 by 2. And j is given directly. It is 5 by 2. And L we found it is 2. Substituting all these values here, j, s and L, if you substitute and simplify, you will get 0.2. And 1 is already there here. So our answer will be 1 plus 0.2. 1.2 is the answer. Option D is the right answer. Next question. A plane electromagnetic wave traveling along positive z direction has its electric field given by. See, without seeing the equation also, I think I can discuss this. A plane electromagnetic wave is there. It is traveling in positive z direction. This is x, this is y, and this is z direction. So that plane electromagnetic wave is traveling along this direction, and then its electric field equation is given. Okay. Now the wave it is traveling in z direction, isn't it? So how that wave will be created? It should start like this, isn't it? Like this. So this is left circularly polarized. So option D is the right answer. Next, in a ruby laser, population inversion is achieved by optical pumping. Option A is the right answer. Okay, I will stop till here in this part. I will upload the next part soon. I will try to finish the question paper in that part. As I said before also, if I have made any mistake, please let me know, and feel free to give your feedback. Okay, thank you.